expanding and condensing logarithms. Alright, we're going to be using three basic rules. The first rule is the product of sum rule. Log base a of xy, x times y, is equal to log base a of x plus log base a of y. Second rule is the quotient to difference rule, which is log base a of x divided by y is equal to log base a of x minus log base a of y. Third rule is the power rule, where we have a base raised to a power, say power b, and that b comes down to be multiplied like so. So we're going to be using these three rules forwards and backwards to try to either condense logarithms into a single logarithm or expand a single logarithm into a bunch of logarithms. We're going to start by expanding. So we're going to expand this as far as we can go. Our first example is going to be common log, which is base 10, when there's nothing written there, of x squared over y squared. Now in this case, again, the common log is missing, or the base is missing, which is base 10, but we just call that the common log. I'm going to use the second rule, the quotient rule, and write down log of x squared minus log of y squared. Now I'm going to apply the third rule and rewrite and bring that 2 down, common log of x minus, and now I'm going to bring the exponent down from the y to make that 2, and the common log of y. So that would be completely expanded, as expanded as we could make it. Let's try another one. Here we're going to have log base 12 of x squared over x plus 3. Now again, I have the quotient rule. I'm dividing in this case, which is rule 2 from above, which is going to give me log base 12 of x squared minus log base 12 of x plus 3. Now I'm going to further use this on the first part here, and I'm going to have this 2 come out in front, using rule number 3 up above. Now this next one, I can't do anything more. The log base 12 of x plus 3 has to remain exactly as it is. I can't distribute the log base 12 into both or anything like that. Rule number 1 does not apply. It just stays exactly like it is. And that's as expanded as we can make that one. Next example is going to be a little bit more complicated. We're going to have log base 6 of 4 x to the third over the square root of y. Now we have 4 bases in this case. We're going to expand them as far as we can expand them. Up top, log base 6 of 4 plus log base 6 of x cubed. So I use rule number 1 for the numerator. The denominator becomes minus log base 6 of, and I'm going to rewrite it as root y in the numerator because we have the minus out in front. I know that 4 is actually 2 to the second power. Sometimes this is necessary, sometimes not so much. Log base 6 of x to the third. Now here, I know that the exponent for y is actually y to the 1/2 power. And now for all 3 of these, I'm going to apply the third rule up above, where I take the exponent and I bring it down in front. This becomes 2 times log base 6 of 2 plus, now the 3 is going to come down from the x, log base 3 of x, and for the y, minus 1/2 is now going to be in front. Log base 6 of y. And that's as expanded as I can make that one. This next one is quite complicated, so this one's going to be a little bit longer. Here we go. If you can do this one, you're doing a fantastic job. I'm going to use the natural log for this one, which is log base e. And we're going to start out here that this is the 7th root of the whole thing. And we're going to have a whole lot going on here. This is x squared times the cubed root of y squared over the square root of z plus 5 close. Alright, so this is quite a large one, so we're going to have to go a little slow and take our time with it. Let's start with the big 7th root here. And what we're going to do is I'm going to rewrite the natural log. And this is just going to be x squared times y to the 2/3. We'll just keep it there for now. And below we have z plus 5 raised to the 1/2 power. And because of the 7th root over here, the entire thing is going to be raised to the 1/7 power. All of it. What's going to happen next is I'm going to have to take that 1/7, and that's going to come all the way down in front. I'm using rule number 3 from up above. So that 1/7 comes down. I'm left with natural log of x squared times y to the 2/3. And below we have z plus 5 raised to the 1/2 power. Alright, now we got to keep this 1/7 out here. 1/7. I'm going to put a big bracket there. And now I'm going to use rule number 1 for the numerator, so natural log of x squared plus natural log of y to the 2/3 power. And down below, I'm going to do the minus, which is rule number 2 up above, because I'm dividing by that, of natural log of z plus 5 raised to the 1/2 power. All that in brackets. Now please note, I still have the 1/7 out in front. We just need to kind of keep that hanging out there for right now. Next up, we have the 1/7. And inside the brackets, I notice I have natural log of x squared up above. That 2 is going to come down. And I'm going to get 2 times the natural log of x. With the y, we have it's raised to the 2/3. That's also going to come down. 2/3 natural log of y. And for our minus here, we're going to have minus. And the 1/2 power comes all the way out in front again, using rule number 3 from up above. Now again, the z plus 5 just stays as it is. Rule number 1 does not apply, nothing crazy like that. So we're not going to any distributing or anything like that. However, now we are going to distribute the 1/7 to each of these logs. So 1/7 times 2 gives me 2/7 ln of x. 1/7 times 2/3 is going to give me plus 2 over 21 natural log of y. Also the 1/7 is going to stretch all the way over to here. I'm going to get minus 1 over 14 natural log of z plus 5. Whew. And that is our final answer. That is a crazy answer there. Crazy problem. If you didn't follow that one, that's okay. You can go back and review it a few times. But this is definitely a more complicated one. The previous 3 examples, you should be able to follow those, hopefully. All right, so now what we're going to do is we're going to condense into a single logarithm. So we're going to go backwards from what we just did. So let's start with an example. Start with a nice simple one. We'll go log base 2 of 5 plus log base 2 of x to the 3rd. Now notice rule number 1 from before is going to apply. Notice I have a plus in between, and so I'm going to go backwards and condense it into a single logarithm by multiplying log base 2 of 5 times x to the 3rd power. So now it's been rewritten as a single logarithm. So we're good to go. Next example. Here I have 2 log base 7 of y plus 6 log base 7 of z. Now rule number 3 is going to apply here. I notice I have the 2 out in front. That's going to move here and become the exponent. Same with the 6. So log base 7 of y squared plus log base 7 of z to the 6th. Now, again, rule number 1 is going to apply because I'm adding in between. So this is going to give me log base 7 of y squared, z raised to the 6th power. And there we've condensed it again into a single logarithm. Alright, we're moving along. Next example is going to be a little bit more long, and then the last example we're going to be doing is going to be a little bit crazy, like before with the expanding. So we're going to have log base 6 of 18 plus log base 6 of 2 minus log base 6 of 9. And I'm going to notice I don't have any exponents to bring up, so I'm just going to go straight to rule number 1 and 2. We'll start out with rule number 1, log base 6 of 18 times 2 divided by 9. And I notice these are all just numbers, so we can just sort of crunch them together. I have 18 times 2, which is 36, and 36 divided by 9 is 4. Now we have a choice. I could take 4 and break it into 2 raised to the 2nd power and bring the 2 down, but in this case I'm just going to stop here. Previously we did break it down like that. I just want to show you that it depends on the problem, it depends what your teacher is asking for. Sometimes you do, sometimes you don't. So we'll just leave it this time. Alright, last example is a long one. 3 log base 2 of x plus 1/2 log base 2 of x minus 2 times log base 2 of x plus 1. So I notice I have several pieces that are going to turn into exponents here. So I'm going to apply rule number 3 first and bring those exponents up. So this is equal to log base 2 of x to the 3rd plus log base 2 of x to the 1/2 power minus log base 2 of x plus 1 to the 2nd power. Now I have all the exponents taken care of, which we've been doing first, which is necessary. And now I'm going to apply rule number 1 and 2. We'll start with rule number 1. Log base 2 of, I have x to the 3rd power times x to the 1/2 power divided by x plus 1 raised to the 2nd power. Now up above in the numerator, I have x to the 3rd times x to the 1/2. And so I'm going to go to my scratch paper over here. X to the 3rd times x to the 1/2 power. Now if you remember, there's an exponent rule that says when you multiply the same bases, you add the exponents. 3 plus 1/2. Or x raised to the 6/2 plus 1/2, which is x to the 7/2. Coming back to our problem, back here in the numerator, log base 2. In the numerator, the x to the 3rd times x to the 1/2 power, if I go to my scratch work, that all just becomes x raised to the 7/2 power. Down below, I have x plus 1 raised to the 2nd power. And there we've condensed it into a single logarithm.